Welcome to our deep dive into the world of
Generative AI
generative AI
and
and
retrieval language model
large language models. Yeah, we're using this pretty interesting YouTube
for
course.
freecodecamp.org.
Yeah, from freecodecamp.org as our guide.
And they really packed it with,
They really did pack it with some
we're going to
insights.
explore not just the what, but the why,
Okay.
examining the evolution of these models
Mm.
and their impact on how we interact with information.
Okay, so let's start with the big picture then.
Okay?
Generative AI. Um, I'm picturing like an artist creating a masterpiece, not just like sorting through existing ones.
Yeah.
Am I on the right track there?
You are. It's about creating, not just classifying. Think of it as a subset of AI
Okay.
that uses deep learning and neural networks to generate new content.
Okay.
Text, images, music, you name it. And it's a field that's constantly
Constantly evolving.
evolving. Yeah. Now, speaking of evolution, the course mentions RNNs and LSTMs,
Yes.
almost like they're ancient history now.
Were these like the stepping stones to what we have today?
Absolutely. RNNs, or recurrent neural networks,
Okay.
were designed to handle sequential data like text.
Okay.
Then came LSTMs, or long short-term memory networks,
Oh.
which improved upon RNNs by allowing them to process longer sequences.
And then, boom, the attention is all you need. Paper in 2018.
Yes.
That sounds like a pivotal moment.
This paper introduced the transformer architecture, which revolutionized the field.
Okay.
Instead of processing information sequentially, transformers use attention to analyze data in parallel,
Wow.
making connections across vast data sets. This leap in efficiency and processing power
Yeah.
is what led to the development of the powerful LLMs we have today, like
Oh.
ChatGPT
ChatGPT, I have to admit, I've been spending way too much time on
on OpenAI. Right?
OpenAI's playground.
Yeah, it's very user-friendly.
It's incredibly user-friendly, and the models are mind-blowing. GPT-3 for text generation,
Right.
DLE for images, even Whisper for transcriptions. Like, the possibilities seem
Endless.
And-
OpenAI has certainly captured the public imagination, but it's important to remember their evolution.
Okay.
They started as a nonprofit focused on research,
Okay.
but transitioned to a for-profit model
Interesting.
to attract investors and scale their operations.
Okay.
This move, along with recent leadership changes, has sparked debate about their future direction.
I see.
Some argue that the for-profit model allows them to accelerate AI development, leading to breakthroughs like ChatGPT.
But does that raise concerns about who controls access to these powerful technologies?
Yeah.
Like, if a single company has too much influence, could that stifle innovation?
That's a valid concern. Critics argue that prioritizing profit over open access could lead to the concentration of power
Right.
and potentially hinder independent research. It's a complex issue with valid arguments on both sides.
It definitely makes you think about the balance between progress and control.
Absolutely.
But for developers who want to harness the power of these models, tools like LangChain seem pretty essential, right?
Absolutely. LangChain acts like a wrapper
Yeah.
for different APIs, including OpenAI's.
Right.
Making it easier to build applications. It simplifies tasks like prompt templating, ensuring that you're feeding the LLM clear instructions, and memory management, allowing the model to retain context across multiple interactions.
That real estate agent example in the course really clicked for me. Imagine an AI assistant that can analyze property listings,
Wow.
understand your preferences, and even negotiate on your behalf. That's where LangChain agents come in, right?
Exactly.
It's like having an AI sidekick.
LangChain agents act as intermediaries, handling complex tasks by breaking them down into smaller steps,
Wow.
interacting with the LLM and other tools as needed.
That's powerful.
It's a powerful framework for building sophisticated applications.
So we've got these powerful LLMs, and LangChain's helping us wrangle them into useful applications. But what about vector databases?
Yes.
They seem crucial for getting the most out of these models.
Think of vector databases as the libraries of the LLM world.
Okay.
They store and manage information in a way that LLMs can easily access and understand.
Okay.
It's like translating human language into a format that the LLM can process efficiently.
So it's all about making that connection between human language and the LLM's internal workings.
Right.
But how do vector databases actually achieve that?
It all comes down to vector embeddings. Imagine representing words as points in space words with similar meanings clustered together, forming these spatial representations.
Yeah.
LLMs use these embeddings to understand the relationships between words and concepts, making sense of language in a way that's similar to how humans do.
Okay, so these embeddings are like a Rosetta Stone for
Yeah.
LLMs,
Yeah.
helping them decipher the meaning behind the words. And to manage these embeddings at scale, we use vector databases, right?
Precisely two popular options are Pinecone and ChromaDB.
Okay.
Each has its own strengths and weaknesses, like cost, ease of deployment, and specific features, for example. Pinecone is known for its scalability and performance,
Oh, okay.
but it can get pricey for large data sets. ChromaDB, on the other hand, is more affordable and user-friendly,
Okay.
but might not be as robust for handling massive amounts of data.
I have to admit, I chuckled when the course mentioned hitting file size limits with Pinecone.
Oh, yeah.
It's those little details that make it feel so relatable. It's like they knew I was struggling to upload a gigantic PDF for my own project.
Those practical challenges are important to be aware of. Vector databases are powerful tools, but they come with their own set of limitations. Finding the right balance between features, cost, and ease of use is crucial for any project.
Now, this medical chatbot project in the course really sparked my imagination. Imagine having an AI assistant that can instantly answer your health questions
Yeah.
based on the latest medical knowledge. Wouldn't that be incredible?
It's a fascinating application, and the course breaks down the workflow beautifully. First, you ingest your data like a medical PDF.
Okay.
Then you generate vector embeddings for each chunk of text, capturing the meaning and relationships within the data. These embeddings are then indexed in a vector database, creating a structured knowledge base. Finally, the chatbot uses semantic search to answer questions based on this knowledge, delivering relevant and accurate information.
But how do we ensure the accuracy and reliability of such a chatbot? Would a doctor actually use it? And what about the ethical considerations of providing medical advice through an AI?
Those are crucial questions. While LLMs are incredibly powerful, they're not a replacement for human expertise. Especially in critical fields like healthcare accuracy bias and responsible use, are all ongoing concerns that need to be addressed carefully. LLMs are tools, and it's up to us to use them responsibly and ethically.
So while the potential is huge, a healthy dose of skepticism and careful consideration are definitely in order. The course also highlights the token limit challenge. It's like trying to explain a complex medical condition to someone who can only remember a few sentences at a time.
Right.
How do we overcome that limitation?
Exactly. LLMs have limited memory in the form of token limits. They can't process an entire medical textbook in one go.
Right.
That's where chunking and overlapping come in by breaking down the text into smaller chunks and creating overlaps between them. We can give the model a running memory of what it's already processed.
So it's like giving the LLM a longer attention span,
Yes.
helping it maintain context as it works through the information. But doesn't that create a trade-off between cost and performance?
Yes.
Larger chunks mean more context, but also higher processing costs.
You're absolutely right. Finding the right balance between chunk size, context, and cost is a key consideration when working with LLMs, and it's not just processing costs that we need to be aware of. The course also brought up the overall expense of using powerful models like GPT-4, especially for large-scale projects.
Yeah, it made me wonder if there are economic barriers to entry for a lot of developers and researchers. Like if access to these powerful tools is limited to those who can afford it,
Right.
could that stifle innovation?
That's a valid concern. The cost of accessing and utilizing these models can be prohibitive for many, which raises important questions about equitable access and the potential for monopolization. However, there is a growing trend of open-source LLM models that offer a potential solution.
Open source models, that sounds promising. Could these models help level the playing field and democratize access to this technology?
They certainly have the potential to do so. Open-source models foster collaboration, innovation, and wider access, which can help mitigate the economic barriers and promote a more inclusive AI landscape. It's an area worth exploring further.
This is fascinating. We've gone from the evolution of LLMs to the economic considerations of using them, and it feels like we're just scratching the surface.
We are. And in our next session, we'll dive deeper into the real-world applications of generative AI, from customizing models to specific needs to exploring its impact on creative fields and beyond. Get ready for some mind-blowing examples.
Okay.
Let's shift gears a bit and delve into how these LLMs actually work.
Okay.
It all starts with tokenization,
Okay.
breaking down language into individual units that the model can understand.
So it's like teaching the LLM a new language one token at a time.
Exactly.
Kind of like how we learn vocabulary.
These tokens are then converted into numerical representations, which become the building blocks for the model's understanding.
Right.
But how does the model actually learn from these tokens? That's where the magic of neural networks comes in.
Neural networks, they always sound so mysterious to me. Is it really like a brain inside the computer?
Well, it's a simplified analogy, but it helps visualize the concept.
Okay.
Imagine a vast network of interconnected nodes organized in layers.
Okay.
As data flows through these layers,
Right.
the network adjusts the connections between nodes, learning patterns and relationships from the input.
Okay.
It's a process of trial and error,
Right.
constantly refining its understanding.
Now, the course mentions something called backpropagation.
Yes.
Does that have something to do with how the model learns from its mistakes?
It's the heart of the learning process. Imagine the model making a prediction.
Okay.
If it's wrong, the error is sent back through the network, adjusting those connections to improve future predictions.
I see.
It's like a feedback loop, constantly nudging the model towards greater accuracy.
So it's like a student studying for a test, learning from their wrong answers and getting better each time. The more data it processes, the smarter it becomes.
Precisely. And with the massive data sets used to train these LLMs, the learning potential is incredible.
Right.
But what really sets transformers apart from earlier models like RNNs is the attention mechanism.
Attention, it sounds like what my teachers always wished I had more of in class. How does this apply to LLMs?
It's about focusing on the most relevant parts of the input. Think about reading a sentence. You don't give equal weight to every word. You focus on the key words that convey meaning.
Right.
Attention allows the model to do the same, selectively processing information to make more accurate predictions.
So it's like having a built-in highlighter emphasizing the important parts.
Yeah.
That seems crucial for handling the complexities of language.
Absolutely. And because transformers use attention, they can process information in parallel, making them much faster and more efficient than RNNs, which had to process words sequentially one at a time.
That's a huge difference. It's like going from reading one word at a time to scanning an entire page at once. No wonder transformers are so powerful.
It's a game changer. And this parallel processing power is what enables these models to handle the vast amounts of data they're trained on.
Wow.
The course also delved into different transformer architectures, like encoder-decoder models.
Okay.
These are specialized structures designed for specific tasks.
Encoder, decoder, it sounds a bit technical. Can you break that down for me?
Imagine translating a sentence from English to Spanish.
Okay.
The encoder part analyzes the English sentence, extracting its meaning.
Okay.
Then the decoder takes that meaning and generates the corresponding Spanish translation. It's a two-step process: understanding and then generating.
Ah, that makes sense. So it's like having two specialists working together, one deciphering the code and the other creating the output. And these architectures are constantly being refined and improved, leading to new and more powerful LLM models.
That's the exciting part. This field is constantly evolving, with researchers pushing the boundaries of what's possible.
It is exciting.
Now let's circle back to OpenAI and their transition from nonprofit to for-profit. It's a decision that has sparked a lot of debate.
It's a complex issue, and I can see both sides of the argument. On one hand, becoming for-profit allowed them to attract investment and scale their operations, leading to rapid advancements like ChatGPT.
Right.
But does that come at the cost of open access and potential control by a single entity?
That's the crux of the debate. Supporters argue that the for-profit model allows OpenAI to accelerate AI development, ultimately benefiting everyone. They point to the impressive capabilities of models like ChatGPT as evidence of their success.
But critics worry that prioritizing profit over open access could stifle innovation and concentrate power in the hands of a few.
Yeah.
They argue that a more open approach with wider access to research and development would lead to a more diverse and inclusive AI landscape.
It's a valid concern. The balance between progress and control is delicate, and finding the right approach is crucial for the future of AI.
For sure.
The recent leadership changes at OpenAI, with Sam Altman returning as CEO after a brief period of upheaval, add another layer of complexity.
Yeah, it definitely raises questions about their future direction and how they'll navigate these complex issues. But let's get back to the practical side of things we were discussing. LangChain and its role in building LLM applications, what makes it such a valuable tool for developers?
LangChain provides a streamlined way to integrate LLMs into applications,
Okay.
offering features that simplify the development process.
Right.
One key aspect is prompt templating.
Prompt templating, is that about making sure the LLM understands what we want it to do, like giving it clear instructions?
Precisely, prompt templates help structure the input to the model in a consistent way,
Okay.
ensuring more reliable results instead of relying on trial and error. Developers can use predefined templates to guide the LLM's responses.
So it's like having a recipe book for LLMs,
Yes.
guiding them to produce the desired outcome. What other features does LangChain offer?
Another crucial feature is memory management. Remember those token limits we discussed?
Yeah.
LangChain helps work around those limitations by keeping track of previous interactions with the model, allowing it to maintain context over extended conversations.
It's like giving the LLM a longer attention span.
Right.
So it doesn't forget what's already been said. That seems especially important for applications like chatbots, where maintaining a coherent conversation flow is crucial.
Absolutely. And LangChain doesn't stop there. It also provides seamless integration with external tools, including those powerful vector databases we discussed earlier.
Now we're getting into the real meat of it. How does LangChain help connect LLMs to these vast stores of knowledge?
It acts as a bridge, allowing LLMs to tap into the power of vector databases and leverage those semantic embeddings we discussed. This connection opens up a world of possibilities, enabling applications to access and process information in a way that was previously unimaginable.
It's like giving the LLM access to a massive library where it can instantly retrieve and analyze information based on meaning and context. That's incredible.
It is. And with tools like LangChain making these connections easier than ever, we're seeing a surge in innovative applications that leverage the combined power of LLMs and vector databases.
Yeah.
Remember that medical chatbot project we talked about?
Yeah.
It's a perfect example of how these technologies can work together to create truly impactful solutions.
It makes me wonder what other groundbreaking applications are just around the corner. We've covered so much ground today, from the inner workings of LLMs to the tools that are helping us harness their power,
Right.
but there's still so much to explore.
And that's what we'll do in our next session. We'll delve into the real-world applications of generative AI, from customizing models for specific tasks to exploring its impact on creative fields like art, music, and writing. Get ready for some mind-blowing examples that will showcase the transformative potential of this technology.
Welcome back to our deep dive into the world of generative AI and LLMs. We've explored the technical foundations and the tools that are driving this revolution. Now it's time to get practical and explore the real-world applications that are shaping the future.
We've talked about the potential, but seeing these models in action is truly mind-blowing. One area that's particularly exciting is the ability to customize LLMs with specific data.
Yeah, the course mentioned how companies are training these models on their own data sets to create specialized AI assistants tailored to their needs. It's like having a team of AI experts working behind the scenes.
Imagine a financial institution training an LLM on their historical transaction data.
Okay.
The model could then be used to detect fraud, analyze market trends, and even provide personalized financial advice to customers.
That's incredible. It's like having an AI that understands the nuances of their specific business, making it much more effective than a generic model.
Exactly. And because these models can continuously learn and adapt, they become more powerful and accurate over time. It's like having an AI that grows with your company, constantly improving its expertise.
The course also touched on the use of generative AI in creative fields. I've seen those AI-generated artworks and music, and it's both fascinating and a little unsettling. It makes you wonder, what does it mean for human creativity if a machine can create art?
It's a question that sparks a lot of debate. Some argue that AI is simply a tool, an extension of human creativity, allowing us to explore new possibilities and push the boundaries of art. Others believe it's fundamentally changing the definition of art itself, blurring the lines between human and machine creation.
It's a fascinating philosophical question, and it's not just limited to visual art and music. We're seeing generative AI being used to write poetry, create realistic images, and even generate entire scripts for movies and TV shows.
The possibilities seem endless, which is both exciting and a little daunting. As these models become more sophisticated, we need to consider the ethical implications and ensure they're used responsibly.
Yeah, the source material brought up some valid concerns about potential biases and possibility of misuse. If these models are trained on biased data, they could perpetuate and amplify those biases in their output.
That's a crucial point. We need to be mindful of the data used to train these models and ensure it's diverse and representative, and we need to be vigilant about the potential for misuse, from generating fake news to creating deepfakes that could be used for malicious purposes.
It's like any powerful tool, it can be used for good or for ill. We need to establish clear ethical guidelines and safeguards to ensure that generative AI is used to benefit society, not harm it.
Absolutely. Responsible development and deployment are essential. We need robust testing procedures, ongoing monitoring, and a commitment to transparency to build trust and mitigate potential risks.
The course also touched on the economic side of things. We discussed the cost of using models like GPT-4 and the potential for creating economic barriers to entry for smaller players.
That's a valid concern. Access to these powerful models can be expensive, which could limit their use to larger companies and organizations with significant resources. It's important to find ways to make these technologies more accessible so that everyone can benefit from their potential.
But there's also this growing trend of open source LLM models, which seems promising. Could this be a solution to the accessibility problem?
Open source models offer a more inclusive approach, promoting collaboration, innovation, and wider access. They allow researchers and developers from all backgrounds to contribute to the advancement of AI, fostering a more diverse and vibrant ecosystem.
That sounds encouraging. It's like democratizing access to this powerful technology, ensuring that it's not just controlled by a select few. But even with open source models, there are still challenges, right?
Of course, developing and maintaining these models requires significant expertise and resources, and ensuring their accuracy, reliability, and responsible use remains a top priority. It's a collective effort that requires collaboration, transparency, and a commitment to ethical principles.
This deep dive has been a whirlwind of information. We've explored the technical complexities, the potential benefits, and the ethical considerations of generative AI. It's clear that this technology is poised to revolutionize countless aspects of our lives.
It's a rapidly evolving field, and we're just beginning to scratch the surface of its potential. But one thing is, certain generative AI is here to stay, and its impact will be felt across industries and societies.
So, what's the biggest takeaway for our listener today? What should they be thinking about as they continue their own exploration of generative AI?
Stay curious, stay informed, and stay engaged. This technology is evolving rapidly, and it's crucial to keep learning and asking critical questions. Explore the different applications, consider the ethical implications, and be part of the conversation shaping the future of AI.
I couldn't agree more. This deep dive has been eye-opening, and I'm both excited and a little apprehensive about what the future holds for generative AI. It's a powerful tool with immense potential, and it's up to all of us to ensure it's used responsibly and ethically. Until next time, keep exploring and keep questioning.